The ultimate green energy is being grown in Wooster, Ohio. But with enough water, it can be grown nearly anywhere.
It has the potential to produce a domestic source of energy, create jobs for the people of the state of Ohio and the entire country as a whole, and do it in a sustainable way.
Whether you call them an algae farmer or not, you'll see large-scale production of algae. There's no doubt about it. I think there are probably a couple of technology thresholds to really push it to the next level. But even right now in its current state, it can be economically viable. I fully expect to see a lot of businesses being created producing large amounts of algae.
The opportunities for algae are absolutely huge. I mean, we all think biofuels. Biofuels are important, but there's many things you can make from algae. You can make plastics, rubbers, you can make nutraceuticals. And when you look in the future, the farms that will be able to extract all those different pieces of the value chain, I think, are where you're going to see the algae play.
We work on biofuels. I think right now most of the our transportation is using a non-renewable source from the petroleum. The biofuels is an option because it's produced from biomass, is renewable, and also very important, it can be domestic.
Walk into Dr. Yibo Lee's Ohio State University lab, and you might just think you've uncovered a mad scientist lab. Glass tubes bubbling with a light green substance? This is the stuff 1940s horror and sci-fi movies were made of. But what is happening here is actually quite remarkable.
So my role is to attempt to use wastewater streams as a nutrient source to grow microalgae for the eventual use as a biofuel source. What we do here is we produce the seed that we can eventually use out at the farm. So you need a seed culture, a high density culture, before you increase the amount of volume that the algae are going to grow in. So with the bottles that we have here, we're trying to get that density very high until we have enough so that we can test at scale.
For the algae project, carbon dioxide, or CO2, generated by Cedar Lane Farm's coal-burning greenhouse heat system, will be pumped into the ponds, keeping excess CO2 from being released into the environment and providing algae with the CO2 needed to grow.
This project is an integrated process, so what we're trying to do is be as environmentally friendly as we can. So we're taking industrial CO2, we're using that to grow algae. We're then going to take the algae and extract the oil from the algae and take the leftover algae biomass, and we send that over to OARDC with Dr. Lee. They use that material for anaerobic digestion studies to then produce biogas and other forms of energy.
The anaerobic digestion process is one where you take waste streams from multiple sources, say municipal solid waste, food waste, basically anything. You can throw it into these big digesters with a specific type of bacteria, break down the carbon that is in those waste streams, and produces methane and CO2, which combines to form what we call biogas. At the end of these cycles of anaerobic digestion, there's a waste source called effluent at the end. And inside this effluent is a very high amount of nitrogen and phosphorus.
Dr. Lee discovered that the nutrient-rich liquid effluent that remains after the biodigester is finished turning waste into methane can be used to feed the algae instead of commercial fertilizers, making algae the ultimate green energy.
The most important nutrients required for algae growth is the nitrogen and the phosphorus. So the effluent has the exact nutrients required for algae growth.
So we can take the waste material from that process and use it to feed the algae. So we end up closing the loop and utilizing all of the products that are generated from algae to then lower the economics, improve the economic viability of utilizing algae as a crop.
Phil Lane heads Touchstone Research Laboratories Algae Project, which partners with Dr. Lee's anaerobic digester research at the Ohio Agriculture Research and Development Center. Together, they are developing innovative technology for efficiently growing algae in open ponds for production of fuels and other high-value bio-based products.
One nice thing about algae is it grows really, really fast. So unlike some of the other traditional agricultural crops where you plant the seed, you do all the cultivation work, you water it and it grows, with algae it's a little bit different. We can start with a very small amount of material, and in a relatively short time we can have thousands of gallons of material that contain algae. Depending on the algae can double its mass anywhere from 24 to 48 hours. So it makes it's a very quick growing crop, if you will.
For the algae production, we don't need the regular farmland, so it will not compete with food or animal feed for the land. We can grow algae in the whatever where we can build the pond. It doesn't need to be farmland.
The other thing that's interesting is when we started, it was an open question whether you could actually grow algae in this kind of climate. A lot of people think, oh, you should be in the south. Actually, as it turns out, I think you're going to find that this is a very good place to grow algae. Ohio is sort of unique in that it's got a lot of flat land, it's got a lot of water. So the ability to scale these kinds of things up, I think, are very natural for this state. And I think with our technologies added into that, I think we could end up seeing a whole new industry, not only of algae growing, but of the various products that come off of algae. We have a phase change material that we float on the top of the water, and it does a number of very wonderful things. The first one is it reduces evaporation. Ponds of this size could lose 500 gallons a day, which in this area where we have plenty of water isn't as big a deal, but through much of the country, that's just huge. Secondly, we can use the characteristics of the phase change, which are when the temperature drops below 60 degrees, it starts to want to solidify and gives off heat to keep the algae warm at night. So we can temper the cold nights by using this material as well.
The material that we're using so far, we're seeing roughly about a 90% decrease in evaporative water loss. And that will improve the economics of growing algae. The other thing that we're looking at is we're studying what effect it has on the algae being produced with this material. We're studying whether the growth rates increase. Does the amount of lipids or oil that's produced by the algae increase, and what effect that has? Because all of those variables will affect the economic viability of algae as a crop.
As it turns out, there are no mad scientists at work in Ohio, just very dedicated scientists who are developing alternative domestic fuel sources and harvesting other valuable oils from algae. Perhaps one day they will be seen as heroes for growing a viable and profitable renewable energy source, decreasing our dependency on foreign oils. And we can say it all happened right here in Ohio.